Thank you for joining us today. This session we would like to share the secrets and strategies behind building a Drupal platform on Google Kubernetes Engine in our real example for our client. Discover how it's possible to manage over 60 sites with flexibility and scalability, and what challenges we had to achieve this goal. A quick introduction about us. My name is Osman Seferov. I'm technical project manager at Smile, with more than 13 years of experience as developer, dev lead, and technical project manager of Drupal-based projects, different cloud-native technologies, and Kubernetes. I will now hand it over to my colleague Vladislav to introduce himself.
Thank you. My name is Vladislav. I'm from Donetsk region in Ukraine, but I have been living in France for the last 8 years. I have 12 years of experience in web development with 10 years as a project manager and mostly working on Drupal projects. Currently, I am an engagement manager at Smile and also a certified Drupal site builder. A quick introduction of our company. Smile is a leader of digital and open source solutions across Europe, with 2,000 employees and the offices worldwide, with the main office based in Paris region in France. Smile has a long history of working with open source technologies and collaborates closely with its 300 employees in Ukraine, continuously strengthening this partnership over time. If you're interested, tomorrow with Osman we have another session related to the working with Ukrainian Drupal developers during the wartime. So we will be glad to see you tomorrow as well. So today we are going to introduce to you secrets and strategies for building a Drupal platform for GKE for our client Moi Tennessee. The project we are working on is a GKE Drupal platform for Moi Tennessee. The objective is to build a scalable and flexible digital platform to manage over 60 of their brands' websites. As the application, we selected Drupal 10 as the application platform, which is ideal for its flexibility. For infrastructure side, we are using GKE, Google Kubernetes Engine, which offers scalability, robust container orchestration, and seamless integration with Google Cloud Services. This choice also aligns with our team's experience in working with GCP.
Okay, let's dive into Kubernetes. So what is Kubernetes? The official definition is next. It is portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. Looks quite complicated at first glance, but what does it mean in simple words? Think of Kubernetes as a conductor of an orchestra, where the containers are the musicians. It ensures that everything plays in harmony, no matter the complexity of the piece. The right part of the slide represents a high-level architecture of Kubernetes cluster. Each Kubernetes cluster consists of a control plane, also called master node, and a set of worker machines called worker nodes that run containerized applications. The containers operate within the unit called a pod. Pod is an abstraction level over the container, and its smallest deployable unit in Kubernetes. Every worker node needs at least one pod in order to run your application in a container, and each cluster needs at least one worker node to run pods and one control plane in order to control worker nodes. In production environment, the control plane usually runs across multiple computers, and the cluster runs usually multiple worker nodes, providing fault tolerance and high availability. What are the key features of Kubernetes? First, self-healing. Kubernetes ensures that your applications are always running smoothly. If the container fails, it will automatically restart it, replace it, or reschedule it, maintaining the desired state of your application. Scaling. Depending on demand, Kubernetes can scale your application up or down automatically. This ensures that your applications can handle varying loads efficiently without any manual intervention. Third point is deployment automation. With Kubernetes, deploying a new version of the application is seamless. It automates the deployment process, allowing for updates without any downtime. Now let's look at the role of Kubernetes in modern web development. Improved resource utilization, very important. Kubernetes optimizes the use of hardware resources. By efficiently managing the containers and workloads, it reduces the cost and ensures that resources are not wasted. Enhancing deployment speed. Kubernetes accelerates the release cycles. Automated deployment and scaling allows for updates without any downtime, enabling development teams to respond quickly to market changes and customer needs.
The first step in building a scalable Drupal environment is choosing the right architecture. There are two main options to consider: monolithic and microservices architectures. Monolithic architecture is a traditional approach where all components, such as user interface, business logic, or database, are bundled together in a single code base. However, microservices architecture takes a different approach where an application is made up of small independent functions. Each function has a specific service and communicates with others through APIs. Choosing the best architecture depends on your application's needs. For smaller, simpler applications, monolithic architecture can work well. However, for larger, more complex applications that you expect to grow over time, microservices architecture may be a better choice, and it was the case for us. The second step in building a scalable Drupal environment is containerization. This involves packaging an application and its dependencies into a standardized unit, call it a container. This container can be run on any platform that supports container runtime. There are several key benefits to containerizing Drupal applications. First, portability. Containers can be easily moved across platforms. Scalability, they can scale with demand. Isolation, containers provide separation between applications. However, there are some challenges, like complexity, where containerization can complicate your development and deployment processes. So you need to be familiar with the tools like Docker. And state management. Containers are ephemeral, which can be lead to data loss if you don't manage it properly. Despite these challenges, containerization is a powerful tool for scalable Drupal environments. In our case, the containerization was mandatory and crucial. So we can look at the third point.
So after selecting your architecture and containerizing your Drupal application, the next step is to implement orchestration, load balancing, and scaling strategies. And the Kubernetes is an ideal tool due to its powerful orchestration, load balancing, horizontal and vertical auto-scaling capabilities. Kubernetes can integrate with various load balancers like ingress controllers to distribute incoming traffic across multiple Drupal pods, groups of containers. Imagine your Drupal application experiences traffic spike during peak hours. Here is how Kubernetes can help. First, you define a horizontal pod autoscaler HPA object in Kubernetes. The HPA continuously monitors key metrics like CPU usage, response time, and memory consumption, for example. During high traffic period, the HPA automatically increases the number of Drupal pods to handle the load. At the same time, the load balancer distributes traffic across the increased number of pods, maintaining application performance. Then, when the traffic decreases, the HPA scales down the number of pods efficiently using resources. Kubernetes offers a robust and automated approach to managing containerized Drupal applications.
The landscape of application development is rapidly shifting towards cloud-native paradigms, with containerization at its core. By packaging a Drupal application in containers, you can portability across the platforms and flexibility to scale with demand. We follow it a 12-factor approach during the platform build, which provided significant benefits. This approach offers a clear set of guidelines for cloud-native development. If you're interested and we have a time, we can see it after our presentation in details, or if not, we can explore this methodology in 12-factor app website. Additionally, implementing a robust CI/CD pipeline has been crucial for our success in the cloud. CI automates the building, testing, and the integration of code changes, resulting in faster feedback and fewer errors.
Okay, now let's dive into the essential tools that empower a robust CI/CD pipeline for building and maintaining our cloud-native Drupal platform. So everything starts from the code quality. SonarQube acts as our quality gatekeeper, providing static code analysis for identifying potential issues. GrandPHP Task Runner, specifically for PHP, complements this by automating tasks like code style and code standard checking. Version control and automation. GitLab serves as our central repository where we store all the code and all kind of configurations. The integrated GitLab CD functionality, CI/CD functionality, automates the build, test, and the deployment within the pipeline. Containerization and orchestration. Docker plays a crucial role in creating a consistent local development environments using Docker Compose. It allows our developers having very similar to production environments on their local machines. Helm acts as our package manager for Kubernetes. It simplifies the deployment and management of complex applications by managing configuration files as charts. And of course, Kubernetes is a powerhouse behind the container orchestration in our platform. It automates the deployment, scaling, and management of containers. Monitoring. For log management, we use Graylog. It aggregates logs from containers, providing developers with a centralized view for troubleshooting and debugging purposes. Dynatrace provides comprehensive application performance monitoring. And of course, we have the monitoring from GKE itself that is not presented on this slide. Embracing DevOps Magic 8's best practices, our approach to CI/CD and container orchestration is underpinned by top-tier tools. On this slide, we can see the overall schema of the CD pipeline and how developers add their code changes and including Moet-Hennessy core components. So everything starts on developer's local machine, in particular with the composer JSON and composer log file that have dependency to the Moet-Hennessy core composer package that has Drupal core, set of contrib modules used by every project on the platform, and custom Moet-Hennessy solutions like HGate, Store Locator, and many others. So once developer pushes his changes to the GitLab remote repository, it triggers the composer install command at first step. Then the application image is built with all the dependencies and requirements, and the image is stored in the Google artifact registry. On the bottom right part, the application is fully managed by Kubernetes that deploys a new version of the application with the desired state and the number of pods, including all environment variables and secrets. And the latest step is launch of postdeploy.sh script that executes commands like cache clear, config import, database updates, and actually any other commands developers want to launch during the deployment of their application. And they have control over this file. Just an example of the latest project launched on our Drupal platform, the project called sirdavis.com. It's USA whiskey brand project, for which at peak hour we reached over 500 requests per second with a bandwidth of 4 terabytes with a peak of 3.66 gigabytes per second. This screenshot on the right is taken from the Akamai back office.
To conclude, let's quickly summarize the key points of this innovative project. First, the collaboration was the key of our success. The development of this scalable cloud-native Drupal platform was a success of a partnership between Smile, Multi-Tenancy, and Ops team. Each team brought its unique expertise to the table, resulting in a platform which not only meets the current needs, but it's also adaptable for future challenges.
Secondly, the platform scope highlights the achievement of managing over 60 sites for Multi-Tenancy in a centralized and efficient manner. This project exemplifies how the innovation, collaboration, and clear vision on scalability can lead to a powerful solution that meets complex requirements. This platform is not just a technical achievement, but a model on how teams can work together to create something truly impactful. At the bottom, you can see some logos representing the Multi-Tenancy brands. It's just a small, very small part of the websites hosted on by our platform, or the famous one. We also have many other brands websites, business applications, and even e-commerce platforms. Thank you very much for your attention. Please don't miss contribution opportunities during these days. And please fill out the individual session survey, and we'll be very glad to answer any questions you have. Yes, please.
A little bit.
Slow.
Hello, Tim from Omedia.
Hello.
It's an agency from Georgia. Thanks for the great presentation. A question about your experience about migrations and about the rollbacks. What do you do when the deployment fails? It in Kubernetes rolls back to the previous version. What do you do with the database, with the configuration? What's your experience?
Yeah, there is. Thank you for your question. Yes, indeed, there is a mechanism for rollbacks as well, because Kubernetes offers this by default. And in our CI/CD pipeline, we also implemented this mechanism, so the applications are always backed, including database. So if something is going wrong, the application can be rolled back completely, including database. And we also provide our developers with manual launch of such actions like database backup or the whole website's backup, so they can restore when they need this.
Thank you. Okay.
You're welcome. So the question regarding SonarQube and which rules we use for code scan of our Drupal projects. Actually, it's a set of rules. We can say that it's a custom set of rules maintained by our technical experts that is based on the PHP profile. And we add some additional rules for code standards and code styling of Drupal projects. I hope that I've answered the question. Yeah, yes, please.
Yeah, you told us about collaboration and about a very good KPI for the existing website, 60 plus. What was the experience with the onboarding of new projects, new websites and new agencies?
Yeah, very good question. Thank you. So indeed, there are a lot of examples like this when some projects, Drupal-based projects arrive, and they need to be integrated in our platform. And for this, we have a clear guideline for developers. How to work with the platform. We provide a composer-based package and set of rules how to use the platform actually. And developers are free to use any modules and packages they want. They just need to use the core composer package from Moit Hennessy. That includes Drupal core, maintained centrally by our team, and some set of contrib modules that we also control through Moit Hennessy composer package. So I hope I have answered to your question. It's quite good, but it depends. It depends on the experience and level of developers. If they're familiar with the composer approach, there is no issues. So it's only the question of the experience. But again, if there is no enough experience, we try to facilitate this by providing a clear guideline on how to use the platform, how to integrate already existing project in our platform.
So, hi, my question is, how did you handle the database and other services like Redis? If you use Redis or Memcache, do you use the another container for that? Or do you use the Google provide services like Cloud SQL or Memory Store?
Yeah.
Thank you.
So I believe I can show you this slide that I've prepared especially for such kind of questions. So yeah, in the middle you can see what actually happens in the Kubernetes pod. We use a container split approach. So we have Nginx container only for Nginx, and PHP FPM with Drupal. And all of these services are managed services. So we bundle them as managed services. So for database, it's Cloud SQL, yeah, Google Cloud SQL. We use, for example, Redis as well, and yeah, any other services. They are managed services.
Any special reason for that?
Sorry?
Any special reason for that?
Resource?
Reason?
Reason? Well, because it's more simple, I guess. We never, yeah, it's more simple to use already provided by Google managed services, and I think it's question of the price as well. So it was logical to use already providing tools, managed services by Google in our infrastructure.
Quick question about the deployment. So imagine you have updated your configuration for a project. How do you manage the deployment of this new configuration? Do you use the same pod? Do you use the same image but with a different entry point? Or is there another container which manages? I don't know.
Okay.
What's your strategy?
Okay. Yeah. So the bottom part of the slide, you can see the GitLab pipeline. So the first steps is building of application images. So the Nginx, it's a UAT environment. So the first step is application image build. The second one is Nginx image build. Then the deployment process of the application, running the post deploy scripts, and then runtime the application the container. So once we push some changes, for example, to UAT branch, it launch automatic deploy that you see here for UAT environment, and it's completely new application that's built and deployed on the Kubernetes UAT environment. The same for staging environment. we test everything on stage, and we have ready image of the application and staging. Then the same image tested on the stage environment is deployed to production. So basically we take everything tested on stage and we push this image to production. So we're sure that
I think to be more precise, at one point, I believe you have to call drush deploy or drush config import.
Yep.
Where is that?
it is a latest step called post deploy, when the application already deployed.
Yeah. Can we have a more detailed look?
Yep, I can show you right after the session
Okay.
if you're interested. Of
Okay.
course,
I'm very interested. Thank you.
sure. Okay, one more question I see. Is it if it's just quick question?
Is again related to the post-deploy thing. Generally, the site is going to be under maintenance mode during this process. Do you have to take something in account to avoid the monitors to think that the site is down or trying to upscale or doing something? Do you have to turn off some monitoring?
Thank you for your question. Actually, all our websites are covered by Akamai CDN, and even if the application is in maintenance mode for 1 minute or less, it's not visible for end users. For monitoring tools, well, I yeah. Yeah, it's more about props, Kubernetes props. I mean, the Linux readiness and startup prop. Yeah, actually, these props are properly configured. And for example, let's say we have 60 seconds for liveness prop, and it's completely enough for the application to run some commands. And Kubernetes thinks that everything is fine. So it's just the question of the configuration and the tuning. Thank you very much for your attention.